This is going to be the last topic of this particular subsection, and in this topic I'm going to talk about Redshift table maintenance and what tools and commands are there to maintain tables in Redshift. The first tool or command is vacuum. Before talking about vacuum, we have to understand how Redshift table operations work. Let's talk about delete first. So what happens in delete? So let's say this is our table and this is the total size of the table. I have this table data and this entire box is basically, let's say, the size of the table. And what I'm planning to do is that I'm planning to delete rows from this section and this section. So when I run delete command, the rows here will be delete marked rather than deleted, meaning the rows will not be physically deleted, they'll just be marked for delete. And as you can see, it has been only delete marked and the storage remains the same. Storage has not changed. So that's what delete operation does. It actually does not delete the rows, it just marks the rows for deletion. But if you run a select statement on those rows, you will not be able to see those rows because those are delete marked and Redshift will not show you the rows in your output result set. Now let's talk about update now. Update is a little bit more interesting. So let's say I have again this is another table and this is the size of the table and I want to update this portion of data. So what will happen when I run update and the update command completes? So what Redshift does behind the scene, it deletes the existing rows and inserts new rows, meaning the existing rows will be delete marked or would be marked for delete, not physically deleted, and the updated rows would be inserted, meaning the rows with the updated data would be inserted. And let's say if you do it again in this particular portion, the same thing would happen. This particular rows would be marked for delete and then new rows would be inserted, or the rows with the updated data would be inserted. So this is how delete and update works. Insert is pretty straightforward. Insert actually inserts the rows, and select, there's no modification happening, so nothing of this sort happens in select. As you can see that the size of the table does not decrease even if we delete the rows, and size of the table might increase if we update rows because some rows are delete marked and the same number of rows are inserted. So update is a delete plus insert operation. Of course, Redshift has to delete the rows physically. Otherwise, what would happen is that the size of the table would keep on growing and it will have performance impact. Same is the case with updates also. So the rows with delete marks, which are marked for delete, would be removed physically, and this particular space, which is red mark, will be reclaimed. The storage space would be reclaimed, and that's what vacuum does. It reclaims space and also sorts the table data, meaning because of updates and deletes, the physical sorting of the rows based on the sort key might get hampered. So if we run vacuum, it will be sorted. Now let's say I have these rows in a table 10, 20, 30, and let's say I insert new rows. Now if you see, 15 should come between 10 and 20, but that does not happen because these are new rows and the new rows are sorted within that particular set, but it is not sorted globally. And if you insert more rows, let's say 23, 24, 20, 31, 34, 35, so 31, 34, 35 should have come after 30 here, and 31 should have been between 30 and 32 in this particular block, but that does not happen. When you insert these rows, or let's say you update these rows or update the sort keys and you change the sort key, the new blocks are added at the end of the table. Those are sorted, but globally this table becomes unsorted. So vacuum not only reclaims the space, it also sorts the entire table. It sorts the table in its entirety. So this is another table maintenance that vacuum does. If you want to see what will be the benefit of vacuum sort, you can use this SVV table info, and there are two columns, vacuum underscore sort underscore benefit and unsorted columns. And if you query these two, you can actually see whether vacuum sort will have any benefit or not and what is the percentage of unsorted rows in the table. We can see the physical information in Redshift also. using this SVV table info, which you are already familiar with because you have used this earlier to find the size and other table information. Now vacuum has two phases. The first one is sort phase. So what sort phase does, it sorts rows in the unsorted region. So in the previous diagram, you have seen that we had two unsorted regions. So it will sort the rows in the unsorted region. And the next phase is merge phase. In merge phase, what happens? Vacuum merges all the rows that have been sorted in the sort phase, and these rows are merged with the existing rows at the end of the table. As you might have guessed that vacuum is an IO intensive operation and it takes fair amount of IO and resources. And if you have tables with interleaved sort keys, vacuum might take a little bit more time also. The next tool at our disposal is analyze command. Before talking about analyze, let me take a step back and tell you at a high level how the query processing happens. I might have told you already earlier, but let me reiterate. So what happens is that whenever we run a query, whenever we submit a statement, it can be select statement, it can be update statement or delete statement. What it does is that it goes to the leader node in Redshift. So in leader node, the query is parsed, meaning that the syntax and everything is checked. A lot of other thing happens, and then a execution plan is created. So that execution plan tells Redshift how to execute the particular query, where to go, what to perform internally, so on and so forth. Actually, it gets converted into a C++ program and it writes a logic how the record should be read and processed, etc. This entire process is called query planning to create the access plan or access path. It is done by optimizer, and optimizer can only plan the query properly if it knows what is there in the table, how the tables are, how many rows are there, etc. etc. These inputs like how many rows are there in this particular column, what is the minimum maximum, take a look at the zone map, what is the where condition, what is the distribution key, what is the sort key, etc. All these inputs go to the optimizer, and based on that the plan is created. Now let's say I have 100,000 rows in my table and I run the SQL statement. So optimizer will create the plan based on that 100,000 rows. Now let's say I load multiple rows, a batch of rows, and my number of rows in the table become 1 million. So it has changed from 100,000 to 1 million, which is approximately 10 times. So now if you run the query with the same execution plan, then the query might not perform properly, and actually it will not perform properly. So what you should do is that you should provide optimizer with proper input, meaning that you should tell optimizer that okay, see earlier you did create the plan with 100,000 rows, now the number of rows are 1 million, and so things have changed in the columns. Now to provide this input, we run analyze command. So it updates the statistics so that the query planner chooses an optimal execution plan. And to update the statistics, analyze uses a sample of rows from the tables for distribution key and all other columns. Redshift runs it automatically in the background after monitoring changes in the workload. And the parameter that helps Redshift running this is auto-analyze. You can disable auto-analyze, meaning that Redshift will not run analyze command in the background, and you should not do it as a best practice. When we run copy command, at the end of the copy command, analyze is run if the table is empty. Now, after that, if you run multiple copy commands, make sure to run analyze once the copy command is completed, and if the number of rows that you have inserted is a lot. When you create new tables with create table as select or select into, you should run analyze, and you can use this particular system table called PG statistics indicator to find out whether a table needs analyze or not. These are the other system tables, STL underscore analyze and sys analyze history, to find out when analyze has run. Most of the times we'll be using PG statistics indicator and sys analyze history system tables.